Today we're going to talk about absolute value equations. Our steps for solving is to get the absolute value by itself first. Then we're going to break the problem into two problems. One where the inside is positive or normal. And one where the inside is opposite or negative. Then we're going to solve each of the problems. Make sure you check your answers in the original equation. With absolute value equations, we're going to get two solutions, one solution, or no solutions. So for the first one, if I have the absolute value of x plus 5 equals 8, I first check to make sure the absolute value bars are by themselves. They are. That's the only thing on the left side. I'm now going to break it into two different equations. One where the inside's normal, x plus 5 equals 8, and one where everything on the inside of the absolute value bars changes. So negative x minus 5 equals 8. I'm going to solve each of those equations. So on the left side, I'm going to subtract 5, x equals 3. On the right side, I add 5, negative x equals 13, and then divide by negative 1. So x equals negative 13. Before I call it done, though, I'm going to plug it back in. 3 plus 5 equals 8. Absolute value of 8 is 8, so that checks out. Negative 13 plus 5 is negative 8. Absolute value of negative 8 is 8, so that one checks. I can put my answer into set notation if I want. Basically, you just put them in the curly brackets. So this one has two solutions. For number 2, I look at it. My absolute value bars must be by themselves first. On this left side, I have absolute value bars, but I'm multiplying those absolute value bars by 2, and I am subtracting 7. Therefore, they're not by themselves. Just like if this was a variable, I'm going to kind of undo my order of operations. I'm going to start by adding 7. I have to add it to the like terms on the opposite side. And then divide everything by 2. Now that the absolute value bars are by themselves, I'm going to split into two problems, a normal and then an opposite. So for my normal, 4x plus 1 equals 6x plus 5. And my opposite, negative 4x minus 1 equals 6x plus 5. For my left one, there's lots of different ways you could do this part now. I like x to be positive, so I'm going to subtract the 4x. And then I'm going to subtract 5 from both sides. So we get negative 4 equals 2x, divide by 2. And negative 2 equals x. On the right side, again, I like my x to be positive, so I'm going to add 4x. Subtract 5. So negative 6 equals 10x. Divide and simplify. So negative 3/5 equals x. When I plug them back into check, I'm going to plug them into the original equation. So I'm going to get negative 8 plus 1 is negative 7, positive 7, 14, 7 on the left side. And then negative 14 and 3. So this one will not work. And then I'm going to use Desmos to check the negative 3/2 real fast. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . When I plug this into Desmos, I find that it will work. Therefore, this is my only solution. This one does not work. So if I write in set notation, it'd just be negative 3/5. For 3, it's a word problem. 7 equals 1 less than the absolute value of x plus 2. Less than means subtraction and a switch. So it's really going to be x plus 2 minus 1. Again, absolute value bars must be alone. So I'm going to start by adding 1 to both sides. So now I have 8 equals the absolute value. I'm going to break it into my normal and opposite. So we have 8 equals x plus 2. That's for my normal. And then my opposite, 8 equals negative x minus 2. Solve each of them. So I'm going to subtract 2. 6 equals x. Add 2. 10 equals negative x. Divide by negative 1. Negative 10 equals x. I'm going to take these and check in my original equation. So 6 plus 2 is 8. Absolute value of 8 is 8 minus 1 is 7. So I know this one will work. Negative 10 plus 2 is negative 8. Absolute value of negative 8 is positive 8. Minus 1 is 7. Therefore, this one will work. I can put my answer if I want to in set notation. So negative 10, 6. And then when I get to 4, absolute value bars aren't by themselves yet. I've got the negative 3 times the absolute value bars. So I'm going to divide both sides by negative 3. So I get absolute value equals negative 4. When I'm looking at it, I can now break it into my 2 equations because absolute value is by itself. My normal, x minus 3 equals negative 4. And then my opposite, negative x plus 3 equals negative 4. I solve each one. So for the left side, I add 3. X equals negative 1. For the right side, I'm going to subtract 3. Negative x equals negative 7. And divide by negative 1. X equals 7. I plug it back in. So negative 1 minus 3 is negative 4. Absolute value of negative 4 is 4. Times negative 3 is negative 12. So that one does not work. 7 minus 3 is 4. Absolute value of 4 is 4. Times negative 3 is negative 12, not positive 12. So that does not work. So there is no solution. If we did it in set notation, it would just be empty brackets. And this should make sense. Absolute value is another way to say distance from 0. That's what you guys should have hopefully learned in the past. And if I have the absolute value equals a negative number, that means the distance from 0 is negative, and that's not something that's possible in this real world that we live in. So this told me here, absolute value bars by themselves equals just a negative number is a clue that I'm going to get no solution for my answer.